Good. Good morning. Are you okay? Yes. Did anyone come to my talk yesterday? Yes. Okay, thank you. It's always a good sign when they come back. So, of course, the 90% of the people that did come that aren't in this room, they have something else to say, but we'll just pretend they liked it and they couldn't come to this talk. Okay, good. That makes me feel better about myself. Are you feeling good? Yes, you already told me that. That's great. So I'm going to say something very blunt at the beginning. How many of you know the law of 2 feet? Have you heard of that expression, the law of 2 feet, that if you don't like it, get up and leave? Right? So I'm going to apply the law of 2 feet here. This talk is going back to basics. Right? So there's if you have done extensive work with HTTP and know it inside out, if you know the differences between what an HTTP API is and what everyone and their mother nowadays thinks it is or thinks that REST is, then if you know the difference between these things, you can just get up and leave now, because this talk is going to cover a lot of basic things and also tell you the distinctions about HTTP and REST. If you do leave, I do not necessarily mind. I won't feel bad about it. Please do leave your name by the door. Other than that, we're great. Okay? So, my name is Hadi. I work at JetBrains. I'm hoping that you know us. If you like us, then great. If you don't, also keep that to yourself. And I'm going to start with a very, very bold statement. Okay, that's not bold. Now it's bold. With HTTP, your API is your application, right? And we'll see what I mean by that exactly. How many of you here are Java developers, by the way? Any language that is not Java that someone is using? Yes. Shout it out. Googly? What? Kotlin. There's a Kotlin guy in the room. You're going to love this talk. No. So, most of you are Java. There are some JavaScript developers. I have done web programming with many, many languages. The language that I've been using lately has been Kotlin, which is very fortunate for me as well, because I love the language and I get to work with it and get paid, which is brilliant. It's awesome. So my examples are in Kotlin also because I have written a framework which I'll show you. But the point of the framework and the code examples will be for you to understand the concepts beyond the syntax. Okay, it's very similar in all languages. Anyway, 2 interfaces. This is how we normally think of a web application, right? We think of we've got this humongous kind of thing, which is our web application that's sitting somewhere, and then we provide a user interface to it, which is normally an HTML page with some nice JavaScript nowadays and some AngularJS that goes back and forth and interacts with this web application. And then at some point in time, someone says, oh, I need to access this application in a programmatic way. Right, so how do I do that? Well, I'll provide an API for it, right? Now, the advantages of this are that it's relatively easy. I can use any kind of framework. I can use Java server pages. I can use any kind of MVC framework to create a web application, provide scaffolding, provide views, and have my user go back and forth. But it's also kind of because there's not really been any other way to do things up to this point. You know, it's been pushed down our throat that we've got to do things using MVC model, which is a model view controller. You're all web developers here? Yes? No? Yes. Silence is great. Good. The disadvantages are that you have 2 systems to maintain, right? 2 systems. So now you have your web application, and you have from the other side your API. And then you end up in a situation often where you can do something with your web API, with your web interface, with your user interface that you can't do with your API. Because oftentimes, the API is an afterthought. It's, okay, let me slap on an API now because, you know, an external system wants to interact with me. And you run into these limitations that you cannot no longer, you know, do certain things because it's an afterthought, because it's not something that's been built from the ground up. And if you go to the premise of anything I could do with my web interface, I should be able to do with my web API, then this limitation of the afterthought and this limitation of the limitation itself of the API goes away, right? And that's what I mean by a single API point. So you have one single web application and you have a single API. And your user interface consumes your API. And your programmatic access from other companies, other services, other applications consume that same API. It's a single API, right? If you build that up from the ground, then you get rid of the disadvantages that you would have having a web API and a user interface. Now, how do you do that with one interface? I mean, when I use Gmail, my users want to use this. If I'm programmatically accessing Gmail, my developers want to use that. So how would I kind of form this API? Obviously, we're not saying that you have to have a merge of something of the two. I mean, have this merged in some way that both people could use. But it's about providing a single endpoint that your user interface consumes the API in the same way that other users would. Effectively, what that means is that your user interface becomes your first customer of your API. Right? That same API you offer to external services. That's what I mean by one interface. The advantages of this are what? Well, I get a single interface. So I maintain a one interface thing. Just once. It's a single system. Right? And the API is designed from the get-go, which means I won't run into a limitation that someone says, oh, you know how I can do this via the web? Can I do this via the API? And you say no, until I hack and slap something on later. Right? It's designed from the get-go, because before you can implement something in your user interface, what do you need to have? The API. So it's always there. The disadvantage is that the API is designed from the get-go, right? So that often tends to lead to a lot of problems in terms of redesign. Now, there is a saying that, you know, as developers, what is the one thing that we love to do as developers? Except be prima donnas, I mean beyond that. What? Refactoring? I wish. More people would buy us if that was true. No, what else? No, apart from refactoring. Code, yes. And we also like to create frameworks, right? We love to create our own framework. And often we create our framework when? As soon as we see, ooh, I can extract the library. Ooh, I can extract, ooh, now I can create a framework. And you shouldn't. You shouldn't really ever create a framework until you've had at least 3 or 4 use cases. Because what you're doing effectively is when you're creating a single framework you're creating a framework from a single use case, you are adapting it to that specific use case. Until you don't have a variety of use cases, you can't create a generic framework. And here it's kind of the same issue. I have one use case, which is me, which is the guy that's going to be, or the girl that's going to be consuming this. But I need more. So while it's kind of like a disadvantage, at least you have the advantage over the previous version, whereby you don't have that single use case first until that customer comes to you. But it's still difficult, just like creating a framework. And was it possible? This is the other question. I mean, has it been possible up to now to do something like this? Well, if you think of it, and why am I talking about this now? Because up to recently, I mean, how many of you have done Java server pages? Or any other kind of MVC framework, or anything, yeah? Okay, good. Come on, I'm going to make you raise your hands, otherwise you're going to fall asleep and you're going to get too tired. And it's not been easy. I mean, who loves JavaScript? Don't look at them in a bad way. Up to recently, JavaScript has been very much a copy-paste language. Right? Everybody knew JavaScript? No, everybody knew jQuery, right? And knowing JavaScript was just let's copy and paste information over. But recently, with the slew of, frameworks that are coming out, like AngularJS, like Breeze, like, I don't know, Durandal, which apparently now is merging with AngularJS, there's been Embers, and it started to give JavaScript, people are starting to take it seriously, in the sense that this actually isn't a bad language for me to do some things in. I'm not saying I like JavaScript, I'm just saying. I've got my own relationship with JavaScript. I love to hate it at times. But it is possible now because there has been a tendency, a shift towards very rich client-side frameworks. Whereas before, a lot of times we've been pushing more a lot of the back-end frameworks, right? The rendering everything on the server. Now it's moving a lot to the client. So we've got this push towards the client side. JavaScript, as I said, has become a viable language. And the other thing is that HTTP as a protocol has been really undervalued, right? People really didn't understand HTTP. They just knew it was this thing in the web browser that you put a URL in. But fortunately, in our industry, we have this amazing thing called buzzwords. And these buzzwords are really good because once in a while a buzzword comes out and it allows us to reinvent things and recycle things and then have new things. So we can have new frameworks, we can have new libraries, we can have new trainings, we can have new consultings, we can have new courses, we can have all of these new things around the same things but with the new buzzword. And the buzzword that's been going around lately has been REST. Although this is quite old. Do you know what the new buzzword is now? Who? Shout. Who? What? What? It's okay if you speak louder. RESTful? No, that's not. The new buzzword, mark my words, is microservices. Right? In a couple of years, you're going to have microservices conferences and courses and everything, consulting. I'm a microservice consultant. Anyway, so REST has given this push. And unfortunately, what's happened is that now everyone and their mother, literally, I know a mother that does this, has a RESTful API, which is not a RESTful API. In fact, I have this discussion with one of our teams. We've got a product called UTrack. And they keep saying, access the RESTful API. I'm like, no, it's not a RESTful API. It's an HTTP API. They're like, no, it's RESTful. I'm like, no. But if you say REST, people would, no, it's HTTPI. There's a difference. Okay, but, some always look at the silver lining, and the silver lining of REST is that it's pushed HTTP into the limelight. It's made people actually figure out that HTTP is a cool thing. And what is this HTTP? It's an application protocol. Who knows the oscillator? Who's heard of this? Okay, shout out really loud, where is HTTP on this oscillator? I said loud. Transport, yes? No. Application. And I'll tell you what, look at this slide. It's an application protocol. Right? That's good, because that means you're not looking at the slides, you're listening to me. Brilliant. But I also said it. So you're probably sleeping. It's an application protocol, which means it's not about transporting information, which means it has the notion of things around applications and things that applications need. And these things have been really undervalued. And with this new RESTful thing, people are starting to confuse these characteristics with REST. And it has nothing to do with REST. And I'm going to show you all of these characteristics and what you can do with HTTP and where this fits on the REST model and will eventually lead into what RESTful systems are. Okay? So looking at HTTP 101, let me show you a very quick example of what HTTP consists of. So here I'm going to run this application and then I'll show you the code. And it's going to crash on me, but that's absolutely fine. That's a very, very cool demo. You know the best kind of demo? The one that you can fix on the fly, because then you look like really cool. Can I fix this on the fly? Come on, baby. Show me. Fix. Oh. An applause wouldn't be bad at this time. Yeah, I open a lot of tabs when I open Google. Okay, so I go to localhost 3000 headers, and it says hello. Brilliant, right? Beautiful. Yes, sirree. That's how I roll. So let me just show you this. Ignore this guy for a moment. And what I'm doing here is, so this is, okay, there's a couple of things going on here. This is a little bit of my claim to fame and self-promotion, okay, but it's for you to understand. This is a framework I've written, which, how many of you are familiar with Sinatra? Or Sinatra or Express.js from JavaScript? Right, so this is Express.js but written in Kotlin kind of thing, okay? I call it wasabi because I have an obsession for wasabi nuts. So, so what I do is I fire up an app server and then forget that stuff there, and then I do, if someone accesses headers, just print out the raw headers, okay? And just send back a hello to the server. So this is being printed out on the client side. So you can see that I have host, location 300, connection, keep alive, accept. I have a whole bunch of things here with accept. I have user agents, accept encoding, accept language, content length, right? Now, how many of you know about these headers? Right. These headers are actually useful. They're not the garbage that HTTP sends that is annoying that you just want to get access to the body. Right? These things tell you some interesting stuff. Connection tells you whether you want to keep the connection alive or you want to terminate it. Accept. This is telling you all of the formats that the client accepts. Right? And that's called content negotiation and media types, and we'll see how we can use that. And what you can see here is that this is saying that this accepts text HTML, it also accepts application HTML, and you see that it has a couple of numbers here. Do you know what those numbers are? They're called weights, right? So they're giving the priority of the accept header. They're saying if there's no weight, it means it's 1.0. So it says I accept this, and then with lower weights, I accept application XML, and I accept the last one, which is anything. So what it's saying is that you can send me back anything, but this is how I prefer to receive information. And that's called content negotiation. The user agent is telling me who the user agent is, the browser. Accept encoding is pretty much the same as accept, except it's talking about encoding. And then accept language is exactly the same, but it's talking about the different languages that it accepts. Those are headers. How many of you use those headers in your applications? How many of you write web applications? Right. You can put those headers to a lot of use. And we'll see how. So let's talk about API. This is the typical kind of API that people design or used to design up to about 2 days ago, right? Which was I have a domain.com and I have an endpoint and I send some information. And that information includes a method call with some method name and some parameters for that method call, and I usually get back a response, right? You've all seen this. This is pretty much what? SOAP, right? Who does SOAP? Right. You've heard the silly little joke of give SOAP a rest? Haha, haha. So, this is kind of SOAP. Well, first of all, what's wrong with this? It's very, 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 very apparent what's wrong with that. I mean, it's staring you in the face. No, it's XML. That is the first problem with this. It's XML, but we'll just assume it's XML. But yes, what I'm doing is I have a single endpoint, and I'm sending a post, and I'm giving it the net method name, and I'm giving it the parameters, right? But we can do better than that. Why can we do better? Because we can have multiple endpoints. Why can we have multiple endpoints? Because we can. It's a URL. So we can have multiple endpoints. Why have a single endpoint? If I take now, and instead of put app services, I can have domain calculate age, and I can have domain get customers. What does that give me? I no longer have to pass the method name, right? I can just pass the parameter. It's still problematic. Why? Because it's still XML. But At least now I've got multiple endpoints, right? But if you look at a typical CRUD application, what does a typical CRUD have? It has create, read, update, delete, right? That's what we do. That's what we do the 99% of our lives. We do CRUD. Imagine, it's like my mother asked me, what do you do? I do CRUD for a living. So if you take that and you combine it with the HTTP verbs, now, do you see that little star that says don't take this literally? That means don't say or don't quote me on, Hadi says that CRUD is post, delete, get, blah, blah, blah. No, that's not what I'm saying. But I'm saying if you take that and say, if I can map create to post, read to get, update to put, delete to delete, what does that give me? Verbs. Right? So now I get different verbs that I can use. So now I don't need to do no longer what? I don't have to create an endpoint that's giving me what? The method name. I am creating an endpoint that is something else, which is the resource. So here's the first term that comes in, resource, right? Remember this when we talk about REST. The resource comes in. So now I have a resource and I do a get. What does that mean? I want the resource. If I do a post on the resource, what does it mean? I create a resource. Okay? So now I go from one endpoint to multiple endpoints. Instead of using method names, I'm using resources and I'm using verbs to indicate the operation I want to do with that resource. So that's good, right? We're starting to move on. We're gradually creating a kind of a better API. Why? Because now I don't really have to tell someone, here's the SOAP WSDL. I can say, this is my endpoints. You know what you can do. You can do post, get, delete, put, options, patch. That's what you can do. These are my endpoints. These are the operations. Go knock yourself out. It's not, here is a list of all my method names. Here is a list of all those whatever. Now you know what you can do. Now, I can show you a demo of this. So here's, for example, a very simple example. I'm saying I want to do a get on customer 2. And I say the content type is application JSON. And I send back JSON. Now this is ugly. You don't normally do it like this, right? But if I go to the browser and I type localhost customer 2, it dies on me. Normally it would help if you run. And it says method not allowed, right? But that's okay. Don't worry about it. That was actually planned. No, seriously, it was. Do you know why I put method not allowed? Huh? Because sometimes on some operations you don't want to allow a specific method. Think about it. I have a customer endpoint and I want you to be able to get customers. I want you to be able to update customers. I want you to be able to create customers, but I don't want you to delete customers. So if you initiate 4 or 5 method not allowed, it's saying to the endpoint, method not allowed. You're not allowed to delete or get a customer for a variety of reasons, right? So, but the problem with this is that, what about the client-side support? I'm now saying that let's go past the get and the post. What about how do we access these verbs from the client side? Because the browser can only do get and post, right? Programmatically, if my application is talking to another application, it's okay, because I can use any Apache client or any HTTP client or any socket that I create myself and issue get, post, delete. What about client-side browser? What about the user interface that's interacting with this? Well, first of all, if you're using something like AngularJS to now create your user interface, you don't have a problem, because the majority of AngularJS or jQuery libraries, all of these allow for all of these different methods. If you don't have that possibility, you can use a hidden field, or you can use query parameters and say, I do a get or a post, but then as a query parameter, I actually indicate the verb that I want to execute. Or you can add an extra header in HTTP with the X prefix and say, this is the header that I'm really going to use. Right? So there are ways to work around that if your client-side implementation by the browser doesn't allow it. So allowed verbs. Not every resource allows every method. And with method not allowed, it allows you to restrict what you can do on a specific resource. Yes?
What's the semantic difference between method not allowed and forbidden?
So the question is, what is the semantic difference between method not allowed and forbidden? You tell me. It depends on your domain. If I'm not allowed, I'm not authorized to access something, it means I'm not allowed to see it. If I'm not allowed to delete something, it could be because either I don't have enough permission or because that operation isn't allowed in my domain. So it's really up to you to define that semantic difference. What HTTP allows you to do is differentiate that. And we'll see that when we get to status codes, right? Now, there is actually the ability to, what you need to implement in your applications, right, is this concept of if someone makes a request to my HTTP endpoint, I need to control which methods are allowed. And there's a request that HTTP can do, which is called what? If you make an options verb, that tells you which methods are allowed, right? Which methods you can call on this specific endpoint, on this specific resource, right? So, for example, a lot of the frameworks, including Wasabi, has the ability to just set a configuration and say, enable auto options. And what that does is basically look through the root, see all of the different verbs that exist for a specific endpoint, and then if someone issues an options against that endpoint, it will automatically send back the response. If your framework doesn't do that, then you should implement that manually. Okay? But you need to do that because you need to say to them what it is. It's very important to make an HTTP that is discoverable. This is the key thing. Just like when you design APIs, make them discoverable. The least that I have to go to documentation to understand how something works, the better. For two reasons. One, because we don't read documentation. Two, because people don't enjoy writing documentation. So it saves money for everyone. Now, here's another one. Creating resources and location headers. I do post domain.com/customer, you respond 200 OK. That's wrong. Can someone tell me why that's wrong? Created, exactly. There is a status code for creating a resource. It's 201 created. It's not 200 OK. In fact, there's something even better with HTTP, is that it has a verb, it has a header called location. Do you know what location is? It tells you the location of the newly created resource. So when you do a post normally says, I'm going to create a resource, but I don't know the ID. I want to create a new resource, therefore I can't give you the ID. When you do a post, the server can respond by specifying the URL of the newly created resource in the location header. Right? And that is very, very simple to do again. And it depends how much your framework builds in. But for example, here I have it built in. So I can do something like, where is it? Actually, it's over here. Testers. So I can do something like this. I can say, on server post customer. So the missing part here is kind of like add this to the database. Right? Then I say the resource ID is 20, and then I say set status code created. And what that automatically does is send back a 201 created, and it automatically composes the full URL and sends it back as the resource header under location. So there solves the problem that a lot of people face and saying, okay, if I do a post and I don't know the resource ID, how do I immediately use it? You send it back under the location. This is typical error management. right? Typical. In every application, it's the equivalent of the try something, catch, exception, empty. Or let's just try and catch everything with the top level exception. This is, if something goes wrong, just send a 500. It's okay. Why? Be discoverable. So instead of sending back 500, send back a correct status code. Did you know that there's more than 200 and 500? Well, yes, because I just mentioned 201, right? But you have OK, created. Do you know what 202 is? It's for asynchronous operations. It means I can create a long-running operation, the server responds with a 202, and then in the location header tells me where to poll to see if the operation is completed. Beautiful, right? Support for asynchronous operations built into HTTP. Move permanently, found, not modified. We'll see what this is. The conditional get, bad request, forbidden, not found. All of these status codes exist, and you can normally find something that fits into that status code. For instance, a conflict is when two people are updating the same record. Second one can say, oh, conflict. The more we standardize on a set of rules, the easier and more discoverable our API becomes. Now let's talk interfaces. Here is Checklist. Anyone use it? Brilliant. It's, there's a free plan and there's a pro plan. It's the best to-do list ever. Really cool. Hierarchical, I recommend it. Here's Checklist when I go to it via the web. Here's Checklist when I go to it via the URL. Have you noticed something? Same URL. This is content negotiation. This is saying, I can have different media types represent the same resource, right? So that resource can be media type text/HTML, or it can be XML, or it can be JSON. That is what media types are. And every resource has a media type associated to it. So you can negotiate content. And how can you negotiate content? You do it via content negotiation. Which is, I say, I want customer25.json, I want article1.es, I want 25 format JSON. I don't care how you do content negotiation. You can specify how you want to do it. The most common one is what I mentioned before, which is the accept headers. This is content negotiation. The server, which for example, again, many servers implement, is what this is going to do is say, okay, you want text HTML, you want this and you want that. Let me order it, see what weight it is, see which one you want by priority. Let me try and see if I can give it to you in that format. If I can't, I'll drop to the next one, see if I can give it to you in that format. If I can, I'll send it to you. If I can't, I'll send back a status code saying, I can't serve this content type. But it's the same endpoint, right? It's exactly the same endpoint. And the important concept of this to grasp is that it's the same endpoint, meaning in your application, in your HTTP application, in your code, you should also make it a single endpoint. You shouldn't have 5 different methods for 5 different types of media types, right? Here, for instance, what I do is I say, well, you can actually do something like server enable content negotiation, right? And then automatically, if someone does, where is it? Okay. Instead of doing this, I could just do something like send back customer, right? And customer would just be like a customer object, customer equals object, with some properties, and that automatically does content negotiation. It figures out what it can do. It will figure out if it can serialize in that format and send it back. That's automatic. Sometimes you want to do it manually, so you can do manual. And you say, if someone asks for application JSON, send back JSON. If someone asks for text HTML, send back text. Right? But the point is, single entry, same resource in different media formats. So what about when we talk about performance and reliability in APIs? Some verbs need to be safe and idempotent, right? Safe means that I can execute it multiple times without no harm. And idempotent means that doesn't matter how many times I execute it, it's not going to change value. Now why? Well, because HTTP and the network is not reliable, right? So this is something we need to take into account as well. But guess what? What already has this built in? The internet, proxy servers. All of these things that I've been mentioning are already built into the world. You've got billions of machines out there on the internet which have the concept of HTTP built in. Therefore, you have this large network of computers at your disposition. You have caching built in, max age, which tells you how long something should last. Expires, which tells you a thing expires at a specific date. Normally, you should use this one, because this might often suffer time zones, so normally just put a max age and say 3,000 seconds this lasts. Okay? Conditional get. Anybody know about conditional gets? So the concept of conditional get is that I get a resource, and that resource might not have varied. The server computes some value on that resource, could be, for example, a hashtag of the object, and if the hashtag hasn't changed, it sends back a not modified header, which means now I don't have to pull the entire resource again. So if I have a very large resource, why pull it down again if it's not changed? So you can use conditional gets to speed up performance. And you have to build that into your HTTP by using e-tags. And once again, depends on the server. And I know I keep talking about Wasabi, but that also has that built in. You can just send back a customer, and by default what it does is calculate the hashtag and the hash code, and if it's not changed, it automatically says not modified. If it's changed, then it sends back a header and says this has actually changed and here's the contents. But build that in, because that improves performance in terms of caching. Now, let's get to the final stages. Program state. All of the stuff that I've shown you, we've talked about resources. We've talked about representations of resources, right? Which was the different types of media types. We've also talked about verbs or operations that we can do on these resources. So 3 things. There is one other thing that a program application needs, which is what? Yes, well done. Whoever said state. Brilliant. Awesome. Programs need state. Do you know what Hateos is? How many of you know what Hateos is? Okay, how many of you do RESTful APIs? Right, so more people have put up their hands saying they know what Hateos is than those that... More people have put up their hands saying they do RESTful APIs than those that know what Hateos is. I got some bad news for you. If you don't know what Hateos is, you're not doing a RESTful API. Okay? And this is the main misconception that's going around on the internet. Everyone just writes a blog post about their RESTful API because they think that they use resources and verbs and done. No. Oh, yeah, and if you send back JSON, that's RESTful. No. Hateos, hypermedia as the engine of application state. Okay, it's not the best word to describe it. Hypermedia, what's this? It's Amazon. Amazon's website updates continuously. When you go to Amazon as a browser, do they click on a little... how many of you have looked at the help file in Amazon? Never, right? Oh, Amazon website has changed. Let me just go to the help file and see where I find the new things. No. As it's evolved, what have you done? You've just looked at it and clicked on links. And you've gone from one link to another link to another link to another link. What are you doing? You're traveling the state of the application, right? You, as an end user, as a human being, are going through the different stages of that application. Imagine if you could do exactly the same through through a worker process, through a programmatic API. The API taking you through the different stages of the application, the different states. That is what hypermedia as the engine of application state is. The API giving you the next step, right? So here, for example, when I do a post domain.com order, it sends back a 201 created, it sends back a location saying where my API, where my new resource created is, and it says to me now what you can do on this, get or put. So it's saying to me, you've just created a resource, and from this point on, you can either get that resource or you can update it. That's all you can do. And then it gives me back the resource. And it says, order, 20, description, and it says, oh look, there's a little link here. This is where you can go next. You can go and pay. So the server is driving me step by step through the process. It is defining the workflow for me. Right? How does it do that? It can use XML custom, it can use micro formats, it can use existing formats. That's wrong, the S should be before the colon. Formats Atom, it can use custom formats. You create a media type which is application.vendor.company.domain and then plus XML or plus JSON. The problem with JSON is that JSON doesn't have the concept of hypermedia links. And there's now attempts to create something standard such as HAL or JSON DL. The problem with HAL is that they've gone off the deep end because they now have the concept of embedded resources, and that's wrong. No, resources are resources. Each resource is a resource. Don't throw in embedded resources in your HAL. But you can use JSON. You can standardize on a link. You can say every time there's a field called link, that means it goes to the next state, right? I prefer that over having to create XML. But the point is that the media, that the data that you send back is driving your application. It's saying, this is where you are, this is where you can go. So now what's happened is that state has been transferred from the client to the, from the server to the client. Which gives what? Another benefit. Now you don't have the problem with server farms. Now you can start to scale, right? Because one server isn't maintaining state. The state is being pushed back to the client. What about cookies? Well, you can use cookies as long as those cookies aren't for maintaining state. There's this misconception as well that if I do a RESTful, well, people that do RESTful APIs do it wrong anyway. But if you want to do a proper RESTful API, you say, well, I can't do cookies. Well, yes, you can, as long as it's not for maintaining state. But here's some added benefits. You know the entities, because you know the resources. You know the operations. You cannot do anything other than the operations that everybody knows about. There is no calculate age. There is just a resource on which you can do something. You know the representations, because the media types define it. And now you know the next steps. So you've just made a pretty discoverable API. In fact, a truly RESTful, I don't want to use the term RESTful API because there's no such thing. There are RESTful systems or systems that comply with RESTful with a series of constraints. But let's say that there is a concept of RESTful API. The perfect RESTful API has a single entry point, which is the root. And then from the root, you can start to go all different places because the root defines where you can go. Right? Let's talk versioning. People say, well, with versioning, I can do V1, I can do V2, I can either define it in the API header, I can define it in the HTTP header, or I can define it in the accept header. But the true power of versioning is when you create an API whereby versioning doesn't break previous versions, right? So never remove if you have to, if you don't have to. There is no proper way of doing versioning. There is no RESTful way or unRESTful way of doing versioning. But try and design your APIs so that they don't break. Because one of the things, the added benefits of this is what? If I am creating these APIs that define flow, and there is no requirement for a WSDL for you to import or for you to a contract for you to update, what happens if tomorrow I add new functionality in that media format that I'm giving back? What happens if I add 3 more links? Well, it doesn't mean that existing servers need to break. Doesn't mean that existing clients need to break. They can just ignore those links if they want. If everything else continues to work, it continues to work. If something's changed, you send back a 302 modifier and say this link doesn't work anymore. Now break. Now take some action. But you don't necessarily say, everybody, I've changed my service. Please, everyone, update your WSDL contracts, re-import, and let's go again. Right? Let's talk security. Well, HTTP, you have a, well, okay, that was before Heartbleed, right? I should have said, well, it used to be secure. To be honest, I mean, with the NSA nowadays, nothing is secure, so it really doesn't matter. Just have faith. But you can use federated security, you can use digest, you can use HTTPS, etc. It's just what you can't do is use cookies for authentication when that cookie is using state on the client. Now, having said that, you can. The problem is that then you're not complying with a series of constraints. Therefore, you cannot say my system is RESTful. And why can't it? Does it matter that you can't say it? Of course not. Nobody cares, right? But the issue is that you won't take advantage of many things that the internet infrastructure provides us, such as caching, such as load balancing. These are the things that you won't have advantage. This isn't about me saying I can call my system RESTful or not. It's about knowing the restrictions you have, and if you comply with those restrictions, the benefits you get. If you don't, if you semi-comply with the restrictions, you're going to end up saying, well, this sucks. I went to all this 80% effort, and I really didn't get any benefits. Yeah, because you didn't go that extra mile. Right? It's like people that don't fully understand unit testing and say, well, it sucks. So let's talk REST. This is where we started the session. Level 0 POCs, plain old XML. I have a single entry point. In that single entry point, I define all of the operations that I can do. In those operations, I define the method names and the parameter names. And then we went one step more and we said, let's talk about resources. Let's stop talking about endpoints that are operations, and let's talk about them as resources and applying verbs to resources, right? And once we add that top thing on the pyramid, then we reach what's called RESTful systems, or systems that comply with Roy Fielding's constraints. This pyramid, or this level, is called the Richardson maturity model, which Martin Fowler wrote about, but it's in the book of Leonid Richardson, which I recommend. And he says that, you know, this is where you reach true restfulness, because you're complying with all of the constraints that REST asks you for. Therefore, you're getting all of the benefits that the World Wide Web and the Internet provide you. Because Roy Fielding basically based his dissertation on REST on saying, how can we leverage the infrastructure we currently have? And he said, in order to do that, applications need to be designed with these constraints. If they are, then we can leverage everything that exists. If they're not, well, they're going to miss out on some things. But my thing is, let's not spread the misconception about any HTTP endpoint is a RESTful endpoint, because it's not. So to summarize, HTTP is your application interface. You can have an HTTP API and not have a RESTful API. It's okay. Nothing will happen. No one's going to come banging down your door and saying, you're doing it wrong. Maybe me, but otherwise it's okay. Right? I have a lot of HTTP API endpoints. I don't have many RESTful endpoints, and it's fine. And RESTful systems contain certain benefits when you abide by those constraints. If you don't abide by those constraints, you won't get certain benefits. It's that simple. But don't mix the two concepts. I really recommend that you read these two books, RESTful Web Services by Leonid Richardson, and this is by Ian Robinson and Jim Weber. And it's, they're the guys that now work at Neo4j. And it's REST in practice, or in short, REST in RIP, which is also REST in peace. They didn't think about that one. Okay? So, thank you very much. Apparently, I think I have 2 minutes left for questions, but it's also lunch now. And there's if anybody came to the session yesterday, there's a raffle. If you tweet it, there's a raffle at 1 o'clock at the booth for IntelliJ licenses. Okay? So, but if you have any questions, come up and I'll be glad to answer.